Hello and welcome. In this video, I will show you how to look at the relationship between two categorical variables using a contingency analysis. Let's look at this business problem. The billing department of a national cable service company is conducting a study of how customers pay their monthly cable bills. The cable payment in person at a local office by mail, by credit card, or by electronic funds transfer from a bank account. The cable company randomly sampled 400 customers to determine if there is a relationship between the customer's age and the payment method used. The accompanying sample results were obtained. Based on the sample data, can the cable company conclude that there is a relationship between the age of the customer and the payment method used? Conduct an appropriate test using a significance level of 0.01. First here, we have determine the appropriate test. So the appropriate test for these would be a chi-squared test of independence. Now, the first thing to do is to formulate the null and alternative hypothesis. Null hypothesis states that the customer's age is independent of payment method. And the alternative hypothesis is that the customer's age is not independent of payment methods. And next, we specify the significance level, which is 0.01, and then collect the sample data in order to compute the chi-square test statistic. So we're going to copy this data to Minitab. So here's the data. This is a 4x4 matrix. We have the categorical variables levels. We have in person, by mail, credit card, and fund transfer. And we have the different age groups. So we want to look at the association between payment methods and ages. And so to do this, we will go to Start, Tables, and we have here the chi-square test for association. And we change this to summarize data in two-way table. So this is a two-way table. In the columns area, you press Shift and highlight all the variables and click Select. And then in the rows area, you select the categorical variable payment. Double click on it there. And next, you can click on Statistics to specify which of the outputs you want. Here we want to have the chi-square test. We want to also have a count, display count in each cell. I also want the expected cell counts to also show. So click OK, and then OK again. And so this gives you the results. So right here, we have the observed frequencies, and we also have the expected frequencies. So this is already done for you using Minitab, the observed and the expected frequencies. And normally to determine the expected frequency, you would have to have summed. So for each of this, for this row, the expected frequency would be the sum of this row multiplied by the sum of this first column divided by the total sum of all the values in this. So that's how 9.24 was computed. Anyways, so let's look at this other table output. Here we have the test statistic. We have the degrees of freedom. And what is the degrees of freedom? The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So we have, this is 4 minus 1 is 3, 4 minus 1 is 3, 3 times 3 is 9. So that's how we computed the degrees of freedom. And the p-value is basically gotten from the chi distribution based on this test statistic. So now we can answer the question. So to 2 decimal places, this will be 52.67. Report the Pearson, not the likelihood ratio. So 52.67. Nice work. Next, calculate the p-value to three decimal places. And you already have it here in 3 decimal places. If we want to increase it, you can increase it. But now let's put it to 3 decimal places, and that is 0.000. Good job. So next, we will make a decision based on the p-value or the test statistic. Now, you can either compute the critical value and compare the test statistic, or compare the p-value to the significance level alpha. Remember, if p is low, h will go. So in this case, the p-value is less than the significance level. That means that we will reject the null hypothesis. There is sufficient evidence to conclude that the 2 variables are not independent. Great. So what does that mean if the 2 variables are not independent? It means that there is a relationship between the 2 variables. So based on the sample data, can the cable company conclude that there is a relationship between the age of the customer and the payment method used? Yes, the cable company can conclude there is a relationship between the age of the customer and the payment used, since the null hypothesis is rejected. So when you reject the null, we accept the alternative hypothesis that there is some dependence between the 2 variables. There is a relationship. All right. Excellent. So great job. So that is pretty much how to run a contingency analysis using Minitab.